So, biomechanics is basically the physics of motion exhibited or produced by any living things or beings. There are two subcategories to biomechanics, which are kinetics and kinematics. Kinetics is the study of forces that cause motion, which basically means any forces that have been put onto something. For example, if a football's kicked, it will be the foot and the forces of the foot going onto the ball. And then kinematics is the study of temporal characteristics of motion, which would be when the ball is already moving. The forces that then go onto that ball, like air resistance or any spin that it has while it's already moving, the forces that are exerted onto it. There are three types of motion within biomechanics, which are rectilinear, curvilinear, and true linear motion. Rectilinear motion is any sort of movement along a straight line. For example, for equipment, as shown, the bow and arrow, the arrow would be moving in an exact straight line till it hits the target. Or for an athlete, a sprinter doing the 100 meters would run in a directly straight line. And the line for both of them would be fully straight with no curves. But leading on a line which would be curved would be curvilinear motion, which is any motion that is moving along a curve. As shown, the golf shot, if you hit a draw or a fade, the ball would fly in a curved motion in the air, going from right to left, as shown. Or, which would be an equipment example, but an athlete example would again be a sprinter, but doing the 400 meters going round a corner would then be the curve of the track of which the motion is on. And then lastly, the last type of motion is true linear motion, which is uncommon in sport, but it's when the whole of an object is moving the same direction at the same speed at the same time. And the only real example you could get is skydiving, when the whole body of a person is falling at the same time, same speed, same direction, all downward. Moving on, scalars. Scalars are a value which have magnitude or a unit of magnitude, for example, distance or speed, which use the measurements of meters per second, or for distance, meters. And like an example of that, for speed, the sprinter would be how fast they run their meters per second in the 100 meters, and the distance would be, for example, a javelin throw, what distance as shown the green arrow, like the distance that it went. It would say someone threw it 70 meters, then the scalar would be distance with the units of measurements of meters. And then the more advanced, if you will, are vectors, which are value with both direction and magnitude. For example, acceleration and displacement. An example of a vector being used, as shown, would be a tennis shot. If the ball on a serve, the ball would accelerate from moving 0 meters per second with no direction, and then as it's been hit, the acceleration would then increase to say 25 meters per second with a downward direction or a negative direction or a southerly direction, whatever you like. It just needs to have the direction. And then this is the same for displacement with an athlete, say, doing the 300 meters around the track. They would run their 300 meters, but the displacement would only be 100 meters, but it would be in a negative direction. Moving on to mass. Mass is the quantity of matter that a body possesses. Mass can have both positive and negative effects on performance, with the performer's body mass, or equipment and what kind of mass that their equipment has. For example, for an athlete, a front row or forward rugby player, such as a prop, would it be beneficial for their performance to have a higher body mass, as they'll be able to produce bigger forces when being tackled to help break lines of the opposing team, and also make him better when he's tackling and the opponent as he can create a large force and then knock them down, which would then help his team and improve his performance. And then this is the same for equipment. Again, going back to tennis rackets, they can be used that players have different masses of their tennis rackets, and the center of mass is different. So for some people, they will have more mass in the grip so that they can get more whip on their shots, or they'll have the mass at the end of the racket so that when they come through, gravity will help it and increase their power when they hit their shots. And then weight is the force exerted on a body by gravity. So for a weightlifter to have a larger weight above their head, the force of gravity will increase on them, pushing it down towards the center of the earth, make it harder for them to then lift that. And then if you just look at the weight on its own, it will always be pushing the same amount down with the same gravitational force down towards the center of the earth. And then this is my bibliography.